In this video, we'll be solving right triangles. To solve a triangle means to find the measures of all the angles and all the sides of the triangle. This is a super standard problem in a trigonometry course. Everyone's going to have a problem like this on their first exam, maybe their final as well. Super standard problem. We're going to solve each triangle. In each case, angle C is a right angle, and we're going to round to the appropriate significant digits. Well, the appropriate significant digits is you need to identify the number of significant digits in each number given to you. And then you use the lesser of the numbers, if one is less than the other. So we're given angle A and side C. Angle A is rounded to the nearest minute. And notice that it's a minute that is not a multiple of 10. So this number has 4 significant digits to it. And our side C, doesn't have a decimal point. So coming in from the right, we start counting at the first non-zero number. So this number also has 4 significant digits. So we will be rounding to 4 significant digits. I'm going to draw a picture. I always like a picture. Triangle ABC. C is the right angle. Our angle A, 13 degrees, 47 minutes. Our side C, which is the hypotenuse, is 1,285. Well, note that we know angle A and angle C, their measures, so we can easily find the measure of angle B because they all have to add up to be 180 degrees. We'll do 80 minus 90 minus 13 degrees, 47 minutes. And that's going to give us 76 degrees, 13 minutes for our angle B. Now we need to find our two sides, side A and side B, and I can use this angle A here on the bottom to find each of them. If I want to find side A first, from my angle A, side A is opposite and the hypotenuse is known. So we have opposite and hypotenuse, that's sine. Sine of 13 degrees, 47 minutes is going to be equal to A over 1,288. And then to solve for A, we'll multiply both sides by 1,288. And our side A will be 1,288 times sine of 13 degrees, 47 minutes. And we're putting that right into our calculator. Now, when we round here, we're going to be rounding to 4 significant digits. So when I put this in my calculator, I'm getting 306.1525, but 4 significant digits, when there is a decimal point present, we start at the Pacific side on the left to count 4. So 1, 2, 3, 4. We should be rounding to the nearest tenth. And now we still have to look over and see whether we round up or round down. We're going to get A to be 306.2. And our unit is kilometers. And now we need to find side B. From my angle A, side B is the adjacent side. And we have the hypotenuse, 1288. I wouldn't want to use this side, like I wouldn't try to use like side A and tangent to find side B, because that side A is a rounded number. And we never want to start our problem with a rounded number if there's any way to avoid it. So from side A, or angle A, that's B is adjacent and our hypotenuse, so that's going to be cosine of 13 degrees, 47 minutes will be equal to B over 1,288. And again, we're multiplying both sides by that 1288. Side B will be equal to 1,288 times cosine of 13 degrees, 47 minutes. And then right into our calculator. Now again, we're rounding to 4 significant digits. It's going to be 1,248, and our unit is kilometers again. I do want to point out how much bigger side B is than side A, but that makes total sense because the measure of angle B is so much greater than the measure of angle A. So I use that kind of thing to check myself all the time. You know, the fact that big sides are across from big angles. Let's do another. We're rounded to the nearest tenth, so that's 3 significant digits. Oh, and we're rounded to the nearest tenth again. But since we have a decimal, we're going to start on the left side and count the first non-zero number and everything after that. So 3 significant digits here as well. So we'll be rounding to 3 significant digits. Labeling my triangle. My angle here, 47.8. My side C, 89.6. We can easily find our angle A because they all have to add up to be 180 degrees. So the measure of angle A is 180 minus 90 minus 47.8. Which is 42.2 degrees. All right, labeling my sides, this will be side B, this would be side A. And I'd probably just base everything off of angle B this time because that was my given angle. So to find side B, from my angle B, that's the opposite. And we know the hypotenuse, so opposite and hypotenuse is sine. Sine of 47.8 degrees will be equal to B over 89.6. And we're doing the same thing as we did in the previous example, multiplying both sides. We'll get side B to be 89.6 times sine of 47.8 degrees, and right into our calculator. We'll be rounding to 3 significant digits. We'll get B to be equal to 66 0.4, and our unit is meters. Next, we'll find side A. From our given angle B, side A is the adjacent side. So adjacent and known hypotenuse, we'll be using cosine. Cosine of 47.8 degrees is equal to our side A over 89.6. We'll multiply both sides by 89.6. We get our side A to be 89.6 times cosine of 47.8. Into our calculator it goes, and we'll round to 3 significant digits. We get A to be 60.2 meters. I'm sure you're already noticing this is quite repetitive. I would encourage you at this point to pause the video and try to do the next one on your own. And then, play the video and check yourself. This one's a little different because we've been given 2 sides. Each of these sides have 3 significant digits to them, so we'll be rounding to 3 significant digits. I'm going to start by drawing my triangle. And they've given us side A and side B. Got those backwards. Well, since we were given 2 sides of a right triangle, we don't need trigonometry to be able to find the third side. All we need is Pythagorean theorem. So I would find side C right away using Pythagorean theorem. So C squared is going to be equal to 958 squared plus 489 squared. And personally, I'd just throw a square root over this whole thing and put it right into my calculator at once. I find when I do a bunch of little calculations, I'm more likely to make a mistake than if I just plug it all into my calculator at once. If you find that's not the case for you, then please feel free to do it, find each of these numbers, add them together, and then take the square root. That's totally fine too. Okay, so we get side C to be equal to 1075.5858. And we need to round to 3 significant digits. Since a decimal point is present, we need to start on the specific side and count 3 numbers, and then that's where we're supposed to round to. So 1, 2, 3, we're rounded to the nearest tens, but we still have to look over to decide how we're going to round that. We're going to get side C to be 1080, and our units is miles. Now for the angles. I think I'll find angle A. Because once we find angle A, we can easily find angle B because they have to add up to be 180 degrees, and we'll know angles A and C. All right, so to find angle A, again, I like to use the given numbers rather than a rounded number. So from angle A, our given numbers are the opposite and adjacent sides. So that's tangent. Tangent of our angle A is equal to 958 divided by 489. To find angle A, this becomes tan inverse of 958 divided by 489. We'll put this into our calculator. We get A to be equal to 62.95848. And again, we're rounding to 3 significant digits. We have a decimal point present, so we're going to start on the Pacific side, the left side, and we need to count 3 digits over, and then that's the place we'll know to round to. So 1, 2, 3. I still have to look to the next number to know whether we're rounding up or not. And we are, so that 9 rounds to a 10, so this becomes like a 0 and we carry the 1. We get our angle A to be 63.0 degrees. And then lastly, we'll find the measure of angle B. We know that all our angles have to add up to be 180, so the measure of angle B is going to be 180 minus 90 minus this 63. The measure of angle B is going to be 27.0 because we're trying to round to 3 significant digits here.